Hello, everyone. Hello, witches, wizards, and other magical creatures. Today I'll be presenting a lesson, Defense Against the Dark Arts, Software Supply Chain Security, Attack and Defense, or Lessons Learned Protecting Magic Internet Money Supply Chains. So, welcome. Who am I? I come from California. I was born in America. But I'm neither Californian nor American. I'm a citizen of this world. And I want my currencies to be so too. That's one of the reasons I'm here. So, it's something I like to share with you all. You're all in the same space, and I think you might be able to relate. But yeah, I grew up in a rural town on Northern California with a bunch of muggles and trees, and the ocean was right next to me, so super peaceful, beautiful place. I went to school and studied cognitive science at Berkeley and fell in love with this whole open source medical hardware ecosystem. I just kind of got dropped into. People were making brain computer interfaces with Arduinos and electrodes and plugging them directly into the laptop and measuring electrical activity on your head. I thought it was really cool. And yeah, just from my background, I was just always kind of attracted to safety and security stuff. I like being safe, I like being secure, and that can take many different forms. Getting a job in the tech industry was a challenge for me because I studied cognitive science and not computer science, and I wasn't really ready to go join corporate conglomerate land, but I had student loan debt, and yeah, I ended up getting a job in the Bay Area and just started showing up to these Bitcoin dev meetups and with a friend of mine. And I was drinking beer and eating pizza, and these bearded men were talking about block size, and I was like, that's cool, but I don't get the problem. And it was just a really fun experience, and I just kind of grew affection for that space. And I was still kind of skeptical because I'm a skeptic at heart, but yeah, that was my early introduction to this whole magic internet money scene. And after my first job in tech, I was like, I want to work in security. I want to help open source ecosystems. And working for crypto financial institutions was a step in that direction. I started working at BitGo as an infrastructure and security engineer. I started just building out their infrastructure and migrating a lot of workloads to Kubernetes, securing Kubernetes, infrastructure, and all kinds of things. As one of those scrappy startups, you do everything. You wear many different hats, and I made many different friends there in a lot of different ecosystems. Yeah, and then I joined Facebook for the Novi and DM project, and I spent 11 months learning how the sausage is made over there before joining Coinbase. And Coinbase is actually a company, that's where I send my friends and family to who want to dip their toes in this space, because let's be honest, it's pretty scary for a first timer here. So I'm sure all of you know someone who's been scammed or have been scammed, and I was like, I don't want my friends and family to be scammed. I trust Coinbase, and now I get to work there and protect that product and protect the assets of my friends, my family, maybe even people here, So that's a really cool feeling. Yeah, and I enjoy atmospheres where all creatures are welcome. So I love the Chaos Communication Congress. Actually, the last time I presented anything publicly was there. I gave a YubiKey workshop and presented people on how to protect your digital identities with hardware tokens like YubiKeys. So that was fun. And I'm a fan of Harry Potter and that whole universe. The books came out when I was close to his age, and I was like, damn, no owls came to me, but I'm just a muggle. Can't all be wizards or witches. Yeah, and so the course outline, enough about me. So unfortunately, professors from Hogwarts can't come to Oregon due to restrictions, and Flu Network is out. So Professor McGonagall, she just can't make it. Professor Binns wasn't gonna come anyways. He only goes between his office and his studio. So I don't know why they let him even sign up for this. Yeah, he's kind of boring dude. And Professor Lupin, it was just getting too close to the full moon. He actually moved to Vancouver, but he's just to be safe. I'd rather be safe than sorry. But yeah, this is the outline. Kind of theoretical overview of software supply chain sorcery. What's the voodoo all about? Historical attacks for those who aren't keeping track. It's brief because there's a lot of them. And I'm not keeping track of them all either, but we probably should because they serve a lot of value for us. And yeah, what are some basic defenses we can do? You know, what can you do today? What can you convince your community to do tomorrow? These are like what I hope you can like learn from this. And my slides are boring. They're plain white and black slides. Like I didn't spend too much time making them beautiful, but I will be publishing these, and the notes have a lot of content in them, so you can derive a lot of information and, you know, just sit back and relax. Yeah, before we start class, there may or may not be dementors ahead of us. Security work is pretty dark. There's a lot of suffering, a lot of pain, a lot of loss. So if you're sensitive to security horror stories, you know, just go grab a coffee, sit outside, do a smoke or whatever. But if you're okay, then just, you know, sit back and relax. Okay, dementors. Expecto Patronum is like, that's the spell you cast when you are trying to protect yourself from dementors, or you just want to send a cool message. Like, I don't know if you guys know Harry Potter, but like they can take corporeal shape and take a body that's kind of ghostly-like and silver and ethereal, and they're like, go send a message to Albus Dumbledore or whatever, or, oh shit, there's a bunch of dementors, come protect me. And you know, the source of the Patronus is like finding one of your happiest moments, and you have to conjure that happy moment and expel it, you know, with your wand. And so as an exercise for this group, I'd like you to take a moment and just close your eyes and think about, you know, looking at yourselves introspectively and look at your life and find those happy moments that, you know, for whatever reason, they just surface themselves in your mind. So just take a second. Close your eyes. And take a breath and hold that moment and just let it sit for a second. For me, a lot of the best friends I have come from these open source communities. And I don't know about you all, but I'm sure you've had a lot of great experiences with a lot of loved ones, a lot of friends, a lot of family. And you used some type of open source technology to enable that event or those circumstances. You know, if you visit your parents in Thanksgiving time and feast on turkey, you booked a flight, and that flight was using like Linux software or Apache web service or whatever. If you, you know, have a friends with benefits token, or you have like Ethereum in your wallet right now, like the technology behind that is open source. And so like for me, I want to enable us all to be able to protect those open source projects against the dementors ahead, you know, the ones that we can't quite see right now. But trust me, they're there, lurking in the shadows. So think about it. Hold those open source projects that you love near and dear into your heart, that make you happy and help enable you to, you know, live the life you want to live. And yeah, just talking about like magic open source projects. For me, the beginning was Bitcoin. I know I'm at an Ethereum conference, but this was like magic internet money for me back when there wasn't such a thing as magic internet money. You know, you had anything close to this, and it's just important to think about that it is pretty magical. Like, we have a currency, we have multiple currencies now in human society that have no sovereign state backing them, no sovereign state controlling them. And we're free to send these little bits of information, these little bits of value to whoever or whatever we want. So, you know, it's worth protecting that. And magic internet money is free, and it's open, and it's built on principles that I really stand behind, and I think you all here stand behind those principles too. So I stand and sit with friends, and I'm very happy about that. But yeah, let's dive into some theory. So every good class identifies words that we should all align with. And here I want to align on 3 different terms with you all: loss, safety, and security. So Loss is just any undesired, any unplanned event that causes some kind of negative impact or harm. You can have your smart contract locking funds from all the users. You can have property damage. You can exfiltrate secret key material, like your private keys for signing git commit messages or for signing Ethereum transactions. And that is a loss that, you kind of want to prevent. And losses can occur for two different types of reasons, let's say. They can, happen because of unintentional actions from good people. So someone accidentally slips and turns off like the switch to the data center, and now all your users are denied service. It was an accident. It could have happened to anyone, and you had some type of loss, but you don't fire the person. You just kind of like say, hey, sorry, like let's try and make sure this doesn't happen again. And then you have security, and security is slightly different because you have intentional actions that are causing loss. And it's that intent that's really special, because intent can be hard to prove, in the court of law, and it takes a lot of evidence. And you have these malevolent actors, these bad people that want to cause harm, and why? You don't always know why. And sometimes it's just better not to understand why. You just have to accept that there's bad people there. There's, dementors or other people that want to cause harm. And so let's actually sit and think about who those people might be in the space we occupy, in the ecosystem, if that's a phrase. So Lord Voldemort, he who must not be named, Death Eaters, and Draco Malfoy, because he's cute. So Lord Voldemort, for me, is like a really dangerous person, much more dangerous than that car alarm. Like, Lord Voldemort is like the guy that just makes your blood run cold. The hair stands on your back when you think about him. And he's not even a guy. He's just like evil incarnate. He had a shit life, and he just wants to cause harm and be evil and be well known. Like, he has an ego. There's just a lot of problems with him, and he has a lot of assets to do all the evil things he wants to do. In the world I occupy, Lord Voldemort takes the form of like the Five Eyes or the nation state threat actors, Anyone basically who has over $100 million to burn on destroying any type of system. Like, when you have certain markets with $1 billion, spending $100 million to like take more dominance over that market isn't, unheard of. It happens all the time. And so anyone who has over $1 million to spend on nefarious actions, I just put in that, like, God, he can buy some iPhone 0 days or whatever. He's a scary person. Death Eaters, those are like the little minions that the Lord Voldemort's hire. They're kind of like the troll farms, and wherever troll farms exist, like, they're skilled actors. They have some funds, and they can collectively organize to cause a lot of mayhem and damage. They're definitely way more dangerous in groups. And the really interesting part is you don't know who they are. They could be in this group here, who, if you ever worked at a large company and you ever wondered how many of your fellow coworkers were spies or paid by some other entity to insert bad code or compromise certain systems in your company, then you might be worrying about Death Eaters, They can take many shapes and many forms, and they appear just like us, but when their lord calls, they do the bidding of their lord. And then there's Draco Malfoy people, and Draco Malfoy, he's just a product of a bad environment. His mom dropped him too much, didn't hug him enough, and like, he's really bitter. Like, Harry Potter gets all this cool stuff, and he's like, some poor boy, and Draco's rich and has all those rich kid problems, and you feel bad, you pity the fool. But you also have to be like cognizant of the fool. You have to know that the fool can harm you. And even though he's like misguided and you really want to just like pat him on the back and say it's going to be okay, you also have to like take account that this might be some 17-year-old in Hawaii who's going to SIM swap you and drain all of your funds from all of the accounts that can be, drained by a SIM swapping attack, an account takeover. And it doesn't take too much money to do that. And, they'll do something. Non-malevolent actors, so like the good guys. I didn't really know how to do Harry Potter theme like for this, so I just kind of went with like my experiences, like maintaining projects, my experiences contributing to projects, and running like services, operating full nodes, hosting websites. Like one of the previous talks was about like PHP forum hosting and all the pains of that, and I'm like, I feel your pain, sister. There's a lot of random people who just want to spam you for no reason. I don't get it. And then downstream users, people of the product. So everyone here is probably a downstream user of something or the other. Most likely Telegram and Discord. But yeah, we all might use MetaMask. We all might use Ledger. We're all downstream users of those products, and some of them are open source, like Firefox. Some of them are closed source, and we're just trusting that things go right upstream. But you all might be in one of these buckets here. You all might be one of these people. You all might be both, or many like me. Yeah, and I think we covered some of the underlying premises for this talk, but basically, attackers exist. They take many shapes. They take many forms. I could be an attacker. Don't trust me. And yeah, they want to do harm on the crypto ecosystem. Let's just assume that for now. Don't ask me why. I don't know. Critical systems depend on open source software. Critical systems in the crypto ecosystem depend on open source software. I think we know that already. A lot of the code bases we run are cloned from GitHub or GitLab or private Git servers or whatever, but they're accessible in the public domain. We can review them. We can improve them. We can complain about them. We can do a lot of things with them. It's kind of fun. And, a lot of these projects that we use to move a lot of money are dependent on these upstream projects. And we'll go into that in more detail. Another thing important to know, magic is any phenomena not fully understood. This is my premise. This is how I view the world. I don't understand most things. It's like perplexing. And so most things are magical to me. I'm like, hey, I don't understand it. It's a little bit of magic, or it's a lot of magic, and Ethereum has a lot of magic. The Web3 world, it just blows my mind. Yesterday, I was overwhelmed with all the cool technologies and all the cool stuff I saw. And, I'm here not fully understanding all of them. Most of them I don't understand, and that's okay. I just want to say that. Like, I think it's okay. You guys might disagree. But I certainly want to protect them all. and that might be a fool's errand, but it's something I'm here to go over with you. And in order to protect something, we first must understand, or it's valuable to understand how it can be attacked. So let's talk a little bit about that. High-level attack system view. So I broke this down into a way I like to analyze complex systems. It's like this formula where you have like a computational level of analysis, you have an algorithmic level of analysis, and you have an implementation layer or level of analysis. And this formula I stole from David Marr, who is a neuroscientist researcher who studied human vision back in the day. And he broke down like the processes for vision in the human brain, looking at like computational problems of it, the algorithm of sending that kind of information theory aspect of it, processing light, converting that to a different medium, transferring it to neurons in different regions to break it down, process it, and then reorganize it into this thing we experience called vision, sight. If you close your eyes, it's not there anymore unless you're staring at a really bright light. Also, fun fact, if you close your eyes, you have these alpha waves that really show up. They're pretty unique signatures. And yeah, you all have a unique like alpha wave signature that emanates, and you can measure from the surface of your head. So if you touch your friend's head when they close their eyes, you might be able to feel it if you're super sensitive, but probably not. Anyways, high-level attack system overview. So what's the computationally, what are we trying to solve for? Let's put it on our attacker hat. We're all bad guys or girls or magical creatures. And we want to do some bad. It's the weekend, it's Halloween. Let's do some tricking because I'm tired of all the treating. So bad actors wish to enact loss on a system. I want to attack Ethereum. Let's say I have a better currency and I want to short the Ethereum market and place a bet that tomorrow Ethereum is going to be a lot less than it is today, because at midnight I released the Krakens. Kraken is a brand. I shouldn't say that. I released the demons, and boom, the hack is unfolded, and no one can trust Ethereum anymore because it broke. The system broke. Algorithmically, how would I do that? Well, capitalistic enterprises, like a lot of these hacker organizations, would just say, well, how can we do this? And what's the cheapest one for us that gives us the best bang for our buck? It's like a return on investment problem. So you just put on your little economics hat and say, well, these attacks are a lot easier than these other attacks. And this is our budget, so let's just go with that. For implementation, there's a lot of implementations you can do. Right now for this talk, I'm focusing on software supply chain security. So it's going to be a software supply chain attack. Shouldn't surprise anyone here. But yeah, we're going to target the software development lifecycle of a system. So you all might not be developers here. You might not know what the software development process or lifecycle is. Here's a good figure for that. It shows you the basic flow. I'm a developer. I contribute to a source code management system like GitHub. I add my commits, and then once I add my commits, a build system takes over and builds an artifact and runs it through tests. And it saves that artifact in some type of package repository, whether it's Docker or just like a GitHub release. And then eventually that product is used downstream. And it's used to run your Ethereum full nodes. It's used to, be the MetaMask browser plugin in your browser. And yeah, that's the life cycle. So I think you all should probably be familiar with that. And this next slide is how it can be attacked. So each of these little points are points of compromise. And basically, as an attacker, I look through this and I'm like, these are ways I can get my code to run in this system. And I can leverage these little points of attack. I can find openings and compromise these systems to get my code running on someone else's system. Let's say an Ethereum full node. And this is a different view of the same structure. So this is an attack tree, and an attack tree is kind of cool because at the top you start with the intent. My intent is injection of malicious code. And then everything down there is how can I get my malicious code into a particular system? And this is an enumeration of that. So, me and my little studio with all my attacker friends are going through this and being like, Ethereum, what can we attack and what's easiest for us? And, it's typically a lot easier to go through a side door that's an open window than the front door that's guarded by a lot of security guards. And so this is just kind of a way to map out what the side doors are into a particular system. And then this is the steps involved. Now I have my code in the system. When do I execute it? And for certain peoples or certain attacks, you execute it during certain environments. And you might only run it when your malicious code when you're on a server, let's say a Coinbase server or a Copay wallet server, or when I'm running an Ethereum full node and for some reason there's secrets there, or it's connected with some other bridge, and there's conditional execution, and there's a temporal time. Do I execute code when it's running the build? Do I execute it when it's running in the production environment? Whatever. So just to give you some ideas. And what's this got to do with Ethereum? Well, Ethereum ecosystem includes open community and an open code base. Contributions are welcomed by many people, and some of them could be evil. I'm a Gemini. My twin walks this earth. And sometimes I wonder, what if he didn't? What if I actually had an evil twin inside of me? Maybe I still do. Could be triplets. And what if tomorrow I wake up and I'm evil? What could I do? At my work, are there single points of failure? Could I cause a lot of harm? Actually, there's not. There's a lot of great blog posts on why that's the case. And Coinbase has done a lot of work in making evil people like me not able to break their systems. But you have to ask yourself that in all the communities you live in, what if you became evil? And you might not become evil, but someone might take over your digital identity and do evil things with that, which essentially is you becoming evil, identity theft. Just because it's someone else controlling your identity doesn't mean your identity is not doing evil things. So yeah, here's some random ETH projects, and just this is to give you a little like, hey, what would you do in this situation? So this is the dependency tree for Ethereum, Geth, I don't know, the Go Ethereum full node. And yeah, this is like a lot of dependencies, but not too much. And a lot of them come from Ethereum Foundation sponsored projects, and you think everything's okay. And then you learn like, oh no, there's a vulnerability in my dependency tree. What am I gonna do? Well, first you see like who's pulling in that dependency. In this case, there is a known vulnerability in the current code base of Go Ethereum. It doesn't seem to be a serious vulnerability. You all are sitting here happy today. And yeah, you want to look at like how you can upgrade this. Well, you see it's like a direct dependency, basically direct dependencies and transitive dependencies. And so with direct dependencies, you can actually just go to Go Ethereum code base and update the dependency to a non-vulnerable one if one such exists. But if you have a transitive dependency that uses that vulnerable dependency, you then have to like patch that transitive dependency, So you'd have to go and patch DOP 251 Goja, whatever project that is, and go ask that maintainer to, hey, update your stuff. Here's Hard Hat. I don't know if you all know what Hard Hat is, but it's like a tool to help people write smart contracts in Solidity or Ethereum. I don't know. I'm not an ETH developer, don't tell anyone here. But I know a lot of people use this, and it's hard hat, but soft shell, my friends. There's a lot of code here. There's 318 total dependencies. Only 47 of them are direct. 271 are indirect, which means you don't really see them. You see them when you npm install this, and you have like 2 gigabytes of someone else's code running on your system. And yeah, there's vulnerabilities there. And it's complicated, like trust me, fixing this in corporate environments is complicated, but getting like effort from open source communities is even more complicated. So just check it out. You can go here, you can go to deps.dev, it's a Google project, and see this pretty graph. I like pretty graphs, I like graph theory. Here's another thing, Ethereum Fae, I never heard about it, but it's a thing in the Ethereum GitHub organization. Almost 50%. So this is like how many committers are committing in the individual dependencies of Ethereum Fae, which is a Rust project. And you see almost 50% of the dependencies have 0 to like 1 committer in the last 180 days. And that's not that many. So it means you have 50% of your code base in this project has like most of the dependencies are only being contributed by a single human that you don't know. And so that person is like liable for a lot of security in your ecosystem. Here's a different representation of that. This is again Ethereum Fae. These are the committers, and this is the crates.io metrics download, and then the size of the circle is like the lines of code. You'll see most of the projects in the Ethereum Fae's dependency tree have less than like 5 committers in the last 180 days, 5 individual contributors. Yeah, all it means is like, well, you only need 1 or 2 people in that maintainer tree to bribe them to go to their house with a big wrench or whatever, coerce them to do your bidding. Yeah, here's another example, like, hey, I don't know if you guys got impacted by this, but it happened last week, and what are you gonna do? What's your run book for your project? Are you compromised? Are you using this project even? How would you know? And what's your plan to defend against these types of notices? And what I like about the Rust community is they like see JavaScript community mistakes, and they're like, how do we prevent this in our community? It's really cool to see people learning from other mistakes. Okay, I'm really low on time, so we're gonna really zip through this historical attack stuff, which is great because it's kind of not that interesting. But Reflections on Trusting Trust, it's a great title. That's why I shared it. No, but actually it's like the first time in academic, publishing space, there was like a discussion on how you would like perform a software supply chain security attack. And this is where you backdoor a compiler to always generate backdoored compilers and malicious like login functions. So you have a hard-coded password This happened in 1984, which is, a long time ago, 35 years. DevOps 199 plus parity. I think you all might be aware of this, but I just included this because, someone accidentally killed it. This is like bad code. This is a safety issue. It's not necessarily a security issue, but skeptics like me are like, did this person know? Was this actual bad intent? Event stream. This is what really put skin in my game. I was working at BitGo at the time, and I was really thankful this event happened because it gave a lot more credence to this threat. Like, it targeted Copay, but it could have targeted many more people. And the attackers downsampled to prevent attacks, to prevent exposure to other firms and whatnot. It was very targeted to a specific company. Matrix, you guys use Discord. I use Matrix, and they had a build system compromise. SolarWind, if you guys have ever heard of that, that is the largest one so far for supply chain security attacks, and this is what's bringing institutional money into the space. So yeah, if SolarWind was built more like Bitcoin, they wouldn't have had this problem, but we might not be able to go into that. Crates.io had bad random number entropy. Linux kernel, that got compromised by researchers, academics. SushiSwap, me so curious about how that got introduced. And yeah, question mark, like how do you let a random contractor change the pay address? Bitcoin Dev receives a QA announcement on their mailing list saying, hey, I'm a stranger on the internet and I'm going to attack all of your systems for exercise. Be prepared. How would you all respond if someone sent that email to your guys' projects? Be prepared. Defense, yeah, pray. No, always just, yeah, I'm actually running out of time, unfortunately. I don't know how much time I can take over, but basically, stop trusting if you're in a really critical system. If you have a trusted compute base that has exposure to material that can cause significant loss for the communities you represent, be very careful. Don't trust, just verify. That's the zero trust policy. And I think we all understand the risks here for not just us, but the communities we represent, the communities we participate in. Know who did what, when, where, why, and how. Audit and verify that things were audited correctly. Know your dependencies. What you see is not always what you get. People can change stuff right in front of your eyes, and you don't know unless you validate. Use math, hash digest, and keys can always be compromised. Not your keys, not your crypto, sure, but keys are always going to be compromised. Have a good plan to rotate. If you can't, think of ways to mitigate and protect those keys, but always imagine they'll be compromised one day. And then the rest of these slides are just defensive tactics that, if you guys want to have a breakout session around 5 or 6 o'clock and really dig down into this, let me know, because I'm actually taking way too much time. And yeah, the only other really important thing for you all to do is use two-factor authentication and don't trust SMS. Text messages are not secure. So if that's a news item for you in 2021, I feel sorry for you, but telcos give zero foxes about that. A good friend of mine lost his entire savings account because of this. He woke up and it was gone. I'm like, God, that sucks. I don't want that to happen to any of you. And so if you need to learn how to use a YubiKey, let me know. If you need to learn how to install Google Authenticator and trust the Google gods, do it. But don't use SMS, and please protect your identities. It's very important. Yeah. That's about it. There's a lot of great organizations and entities already out there doing this type of work. And the rest is just a list of defensive tools you can start incorporating into your system. Some of them I've helped create. Some of them I just love that they exist. Some of them are friends that wrote them. Some of them are large organizations. And oh yeah, Record. This one might be interesting to you guys because it's goal is to provide an immutable, tamper-resistant ledger of metadata generated. It's like a supply chain blockchain. So I don't know. I think you all would like to look into that. I would love to learn how we can organize around this problem. And a lot of you organize decentrally. And so if you have like experiences that might help me in that regard, please, come talk to me. Groups that you can join, OpenSSF, super legit. All the titans are there. Microsoft, Google, Facebook, GitHub, blah, blah, blah. Hashbang, it's a little cult I'm a part of. And you can try and join it if you want. It's pretty easy. And if you need help, like just think about the source. The answer's always there. And then, yeah, personally, stay in touch. I apologize for going way over time. And I hope you appreciated the talk. And let me know if you want to learn more about this space, because your supply chain is my supply chain. And we got to protect all the supply chains. It's an expensive problem. And it all starts here in how you think about it. So thank you.